So in this video we will be taking a look at the process hollowing technique, which is also code injection technique. In this we will be creating a process in the suspended state. When the process is suspended, we will replace the legitimate process code with our malicious code, and then we will set the thread to resume the normal execution. So first we will be using the create process w function to create the process, and we will need to get the image base of this process. So we will be using query information process to get the PEB address, and in that process environment block we will at offset of 10 at 16 bytes we will have the image base address for 64-bit executable, and then we will remove this legitimate process code, and we will inject our malicious shell exe into that process, and by getting the thread context. So this thread context is like a save state or snapshot of the registers of the executing thread, that is the main thread. Since we are creating the process in suspended state, the thread all of the thread data registers will be saved, and we will set the RCX register to point to the address of entry point. So I thought it's RIP instruction pointer, but it's not, it's RCX. For 32-bit you need to set the EAX register to the entry address of entry point. So let's create the new process. I have already defined all of this. I copied from the pinwork. So let's go and create process W, and the first one is the string. So let's create notepad.exe, and the second parameter is command line arguments, so that is that can be null, and the process attributes, so we can pass that null, and the thread attributes, this can also be null, and inherit handles false, and we will be creating this startup info. So this startup info contains the some properties of the process during the startup, like its rectangle size, etc. So here you can see this CV defines the size of the structure. We can say startup info s is equals to new startup info. You don't need to initialize any of these. So where we are here, so we have completed 5 parameters. Creation flags, let's set this to 0, and environment, and the current directory null, and the reference to startup info, and the last one is out to the process information. So this out is like we don't need to initialize this process information object, we can directly send that one. So process information pi is equals to new process information. So you will get some process information, and it contains the handle to the process and the thread. So handle to the process, handle to the main thread, and also we will get the process ID and thread ID. So out pi. So at this point we are creating the process, and this creation flags is 4 for the create suspended. So here we can see 04 for the create suspended. So we can say 4 and it will be in a suspended mode. Let's try to run this. And I have created a function get process image base. So let's run this and we should see the new process notepad. So let's close this one. So let's change this to 0x4. Now the process will be in the suspended state. Let's also run the process hacker as administrator. Now let's put a breakpoint at here, and if you run this, and we should see the notepad.exe in a suspended state, and we get the process ID and the this one handle. So let's stop this and let's kill this process. So here you can see at the bottom terminate. Now we have created the process in a suspended state. Now what we want to do is we are going to get the image base of this suspended process. So we can do that using NT query information process function. So the first parameter is the process handle. So we will be sending the process handle to this function parameter, that is proc handle, and the next one is process information class. So there are different process information classes, and depend on what number you pass here, it will be we will be getting that type of information. So the various process information classes are defined by this. So we will be using the process basic information, and depending upon this you will get the structure to this out parameter. So these are our pointers. So 0, the we need to create process basic information, PBI is equals to new process basic information, and out PBI. Oh, there is a third one. So second one is integer and third one is Third one is the out one. Okay, so next we need to pass the process information length. So we can do uint marshal dot size of type of process basic information, and the reference, the last one is out parameter. So uint length is equals to 0 and reference length. Sorry, this is the pointer. So what we are going to do is we can say int ptr temp is equals to, we are going to allocate some size, marshal dot size of type of process basic information. So this pointer can hold those many number of bytes, so we can marshal that into the process basic information. So we can say temp. Now you have the temp pointer, we can marshal that one as pointer to structure. We have the temp pointer pointing to the process basic information structure, and we can say pvi is equals to this one. Now we can go and print pbi dot pub address. So I have already copied this structure from pinwork. It's basically you can accept these two members, everything are the pointers. So you will get the pub address, we are going to print that one. So let's put breakpoint at this point, and let's go and call this one. I have already called this one, get process image base proc handle. So we can just let's run this, and we should see the output address, that is the pub address, and we can verify that using this process hacker. Go to notepad and memory, and here we should see the pub. Here you can see the pub, and if you expand this, if you open this one, thus after 16 bytes you will have this. So this you can see the pub address is starting, pub address is 6F58FE1000. So the same pub address. From here onwards, if you add 16 bytes and this 8 bytes is the image base, you can confirm that using this one. So here you can see 7F F6 77 E7. So if you go to here, write copy execute, and here we should have the base address. So let me quickly search this 7F F6. So here you go. So this one is the image. So I got confused about this 0. So this is the base address. So after 16 bytes from the PEB address. So now you can stop this and also terminate this one. And what we can do is we can say read process memory proc handle, and the base address is pbi.peb address plus 0x10, and the byte buffer. So let's create byte, let's say byte base, new byte of 8. The size is byte base dot length, and the number of bytes read. So we can say this one is int pointer, so I'm not sure. So let's just say int pointer bytes return. Out int pointer, so out bytes return. So we have successfully read the memory from this peb address to the 16 bytes. Now we need to convert these byte array into the integer. So we can use bit converter dot 2 into 64 byte base comma starting index is 0. So this will give you the long value. So I'm going to convert this image pointer is equals to int pointer. So we have the image pointer ready, that is pointing to the this process image base. So I think we are good to go. Now we can put the breakpoint at this one before this process hello 64 function. So this is very similar to the remote PE injection we have seen in the previous videos. So let's run this, and we should see this one as the base address. So here we can see this is the same address as that of the previous notepad.exe. So that means our loader is loading at the same base address because that's empty, I guess. Click on notepad, and if you go to the peb, we have the commit, and here you can see the same address. And if you go to this one, this is the starting image base. So let's go and stop this and also terminate this one. Now we have everything ready. Also I forgot to show you, let me quickly start this notepad, and if you go to this one, if you double click on this, and here you should see the PE file of the notepad.exe. PE file of the notepad.exe. Now what we are going to do, it's similar to what we have done in the remote PE injection. So we got the we have the handle to the process and the remote base, and the raw file is the file you want to inject. So it's similar to uh, get size of address, get image size, and then allocating some size in our own process to parse the PE locally, and then we'll be using another function nt unmap viewer section to unmap this memory, so that we can write and change the production to read write execute. So after unmapping, we are allocating the size and we are changing to read write execute, and it's similar to parsing headers and writing into the that process using write process memory. So from here onwards, it's similar to remote P injection, and then fixing IATs and base relocations. And after fixing everything, we need to get the thread context using get thread context. So this will give you the context structure. So in that, we need to give the RCX value to the remote base address plus entry point, and we will be setting the value using set thread context. So it's a small code, so that's why I did not I'm not writing again. So get thread context, it takes the thread handle and the, this context structure. So context structure, it contains all these flags. You can search for get thread context. So here we can see we have all these flags. So make sure you have this thread context 64.1, and then we will set the thread context using this function thread handle and the reference the context structure. So after that, we can print the RCX value and setting this to the remote base address plus entry point. So let's go and run this one. So we have set the breakpoint at this process arrow function, and let's start this. So the same image base, now we can see the old notepad.exe. Now let's go and click on this next. So the process arrow function gets executed. So let's also put the breakpoint at here. After that, we will use the resume thread to resume the thread. So click on continue. So we will write our malicious PE into the process memory. Now we need to close this one and again refresh this, and here we can see a single private memory region with the our latest payload. Here you can see this is the different payload, that is I'm specifying the normal cmd.exe, that does not have any node dependencies. So it should pop up the cmd.exe if everything goes nice. So let's click on continue, and here we can see the cmd.exe. So we have successfully hollowed out the notepad.exe and replaced that memory with our malicious PE file, and we have resumed the thread to resume the execution of the process. It still says notepad.exe but executes our cmd.exe. So that's all for this process ordering. It's very similar to the remote PE injection we have seen in the previous videos. If you did not watch those videos, I highly suggest to watch those videos, because the parsing PE file and fixing IITs and base locations are the main important thing in this injection technique, or in any injection technique.